Okay, mini lesson on energy diagrams or reaction coordinate diagrams, or what most chemists call these, but it doesn't matter what you call it. What matters is the various parts of it and understanding what it means. Um, okay, so first of all, the energy level of the products is higher than the reactants. That energy had to come from somewhere, so I know that this thing is endothermic. I know that it is endothermic. I'm just going to label that. And then they're just require, okay, yeah, memorization, activated complex. So the activated complex, remember that when we have a reaction, you've got reactants. So let's say A plus B goes to AB. Here, you're going to have something that's kind of like something like that. It's not quite connected, it's not quite reactants, but they're almost there. They're not quite, the bond hasn't been made yet. That's going to be on this downside. So it's not quite products, not quite reactants. It's called the activated complex, and it exists right here. Oh, hate when that happens. Ow. Always fun. Okay. Where were we? Yes, activated complex. The activated complex lives right here. Activated complex. And it is just this point. It is this highest point right here. And then what else are we looking for? Reactants. Reactants live right here. Remember time going forward. Maybe we'll pull that back a little bit. Time going forward here. So reactants are here. Products are here. What else do we got to label? Reactants, products, exo or endo. This is endothermic. Activation energy. So activation energy is the hill I have to get over. And I always start at reactants, right? Unless I'm going backwards. If they ask you the activation energy going backwards, then obviously you start at the products and go to the top of the hill. But activation energy, is this guy right here. Now they can put the arrow out there, they can put it right here. It doesn't matter. It measures the same thing. It measures the energy from the reactants and how much energy that hill I have to get over, which is the definition of activation energy, the hill of energy that I have to get over to get this reaction started, right? So it doesn't matter where the arrow is, it measures from the bottom of reactants to the top of the products. To the top of the activated energy. Wow, it's early. All right, delta H positive or negative. Well, if I take, it's always products minus reactants. So my products are at 0. 0 minus negative 15 is positive 15. So that's delta H is positive 15. And that makes sense because we know that negative numbers indicate exothermic reactions. So this would have to be a positive number, delta H. What else can I point out here? Oh, we can point out what, and I don't say this on this sheet here, but you got to know what a catalyst does. And all a catalyst does is just basically chop off the top of this hill so that the hill is shorter. It doesn't change where the products are, so this distance does not change. This distance does not change from the reactants to the bottom. The only thing that changes is this point here comes down. So the only thing that's going to change is any arrow that measures to the top of this hill. That's it. That's the only thing that's going to change about this reaction if I add, I'm going to label this catalyst. Hopefully you'll watch the video and label that too. That's it, man. Today's short work day. So I hope you get all the information. I hope you remember this stuff, and I hope y'all crush the final. Anyway,